The only thing different today is that we get into angle of elevation and angle of depression. Okay. So if we assume that we have horizontal lines, which if I were to have two different lines that are horizontal, what can I say about those horizontal lines? Yeah, that they're parallel. If they're both horizontal, they're parallel, sure. So what these problems are going to do is they're going to talk about line of sight, which is either like a direct line from some object that's up in the air coming down, or a direct line from something on the ground that's looking up. So if you take this line of sight and you connect those two parallel lines, who really wants to impress me and tell me what you call that? What do we call a line that connects two lines that are parallel? Thank you, transversal, good. And when we did angles earlier this year and two parallel lines were connected with a transversal, the angle of depression is the angle that takes you from the top horizontal line down to the line of sight. The angle of elevation is the one that takes you from the transversal down to the bottom parallel line. What type of angle relationship is created there? Well, that is an angle relationship, but it's not that one. Alternate interior. What do you already learned about alternate interior angles? So if you can just understand that, that's what's on the first page, then we can jump right into the examples. Tarabi, go sit in the back table. I'm gonna have to give you a and then Elisa, you have a calculator? Tarabi, you have a calculator? No. All right. A pediment has a pitch of 15 degrees as shown. If you don't know, heck, I don't know what a pediment is, but it's shown for you up there in the diagram. If the width of the pediment, WZ, is 56 degrees, what is XY to the nearest inch? The test code is capital K, capital R. Okay, so let me draw this a little bit bigger for you so you can see it. And they want to know what is XY. So this is X, this is Y. So this one isn't actually necessarily an angle of elevation or angle of depression problem. And they've already drawn the diagram for you. So they in order to find a side that's missing in a right triangle, they need to give you an angle, which they do, but they also have to give you a side, which from the diagram it doesn't look like they do, but if you look at the word problem, they tell you that WZ is 56. Yeah, you would. Because these are congruent, what type of a triangle is a big triangle? Isosceles. And when you draw, well, I guess it doesn't state it, but just since it's coming straight down, what type of a special segment goes from a vertex of an angle straight down at 90 degrees? We learned about 4 special segments of triangles. One of them went from an angle and it went straight down to the opposite side of altitude. Yeah, an altitude, good. But in an isosceles triangle, an altitude also acts as a median, as an angle bisector and as a perpendicular bisector. So even though I've just really bored you, the point is that segment is cutting the opposite side in half. So yes, I think outward. This WY is going to be half of 56, so it's 28. So I want to know the opposite leg. They're giving me the adjacent leg. What trig ratio do I use there? Tangent, yep. So tangent of 15. Tangent of 15 is equal to, well, the opposite would be the xy that I want over 28. When the side I'm looking for is on the top, what was the shortcut I showed you? Yeah, or you can just say multiply, sure. Yes, slide it in front. So 28, 10, 15. As long as your calculator is set to degrees, you should be fine. Usually on word problems, they're going to tell you where to round. And see here, they said nearest inch. My approach when I grade things is if they don't tell you where to round, I don't really care. Like I can take it several ways. But if they do tell you where to round, I'd be more strict. Yeah, Kenny, what'd you get? 8. Yeah, go ahead, man. You want to answer it? What's up? Okay, but hold on. Answer Kenny first. Kenny always comes first.
Okay. So, we're trying to find the top number, and it's a variable, then you would just take the 28 and multiply it. But if the variable's on the bottom, you would push the bottom. So, like, say if it was flip flop.
Letter on top, and I know here there's 2 letters because that's because it leaves it as a side. And multiply. Letter on bottom, divide. I don't know how easy it is. Yeah. Yeah, that's where SOHCAHTOA comes in. Here, let's play like those Disney sing-alongs, but let's not sing it. Let's just say it. This S stands for sine is opposite over. Over means on top. Opposite over hypotenuse. So if you have sine, it's O on top, H on the bottom. C stands for cosine is not opposite, adjacent over. Very good. And then tangent is opposite on top of adjacent. So because I was given, or because I was looking for the opposite and I was given the adjacent, that told me to focus on the TOA and SOHCAHTOA. And TOA tells me that tangent is opposite over. Yeah, Hattie. Half of 56. That's what the whole thing I was saying. I don't know if I did it wrong in my head. Is it half of 20? 56? Yes, it does. Yes, it does. But we haven't got to that yet, though. You're gonna be my resident unit person in here. I think there was earlier. I kind of noticed that, but it doesn't affect us yet. It doesn't affect us. So go ahead, Jair. What is 28, 10, 15? Yeah, it's around to the nearest inch. 8, okay. See, but now that actually brings up another interesting point. Yes, ma'am. Mm-hmm. I would tell you that, like, I wish either the paragraph was a little bit more descriptive, or that at least the diagram. Like, I wish, because this XY here is not really given a name. They're not like calling it some special type of arch, or there's nothing to indicate that it's supposed to be directly like vertical, right? But it sure looks that way. So maybe I wish the diagram might have done that. But I honestly be I don't, at least for you guys, I think even if it was or it wasn't, you guys would glance over that. I think it's pretty safe to assume that most of you would assume that it is vertical. So if we do assume that it's vertical, we learned earlier this year that if a segment inside of a triangle goes from a certain angle, and in this case it's important that that angle is the vertex angle of the isosceles triangle. It's the one where the two sides that are the same meet. If a segment goes straight down at 90 degrees, well, if it goes straight down at 90 degrees on any triangle, it's called an altitude. There was 4 special segments. There was altitude, median, angle bisector, and perpendicular bisector. But in this case, on a isosceles triangle, when they're coming out of the vertex, an altitude is actually all 4 of them. It's the same. An altitude also acts as a median, also acts as an angle bisector, also acts as a perpendicular bisector. Key word there being bisector. It cuts the opposite side in half. So if they tell you that from W to Z is 56 feet, then WY would be half. You ready? The test code is capital K, capital R, lowercase f, lowercase e. And I didn't need WZ, I needed WY. That's the right triangle. So back to where we got to. Honestly, if Hattie wouldn't have said anything, I'd be a perfect transparency. I probably wouldn't have even noticed. But she's a stickler for detail, so that's good. So this 8 is in feet, but they asked you for the answer in inches. How do you turn inches to feet? No. Okay, I said it wrong. I said sorry. How do you turn feet to inches? Multiply by 12. Multiply by 12. So here's what I find kind of interesting. That depending on when you round, see this 8 that you're seeing on the board is already rounded. Jair's calculator did not say 8. What did it say, Jair? 7.5, and that's actually a pretty that's a pretty good amount off. So if you put 8 times 12, you're gonna get something different than if you put whatever was in the calculator. Like if you leave it in the calculator's memory and then just hit times 12, that's gonna see. I know 8 times 12 is 96. If it's not about me counting it wrong, it's about what should you put. It's not about whether I mark it right or wrong. It's about how should it be done. I've always advocated for you don't round until you're done. If you're gonna round, try to postpone it until the very end. And the very end here would be that unit conversion. So I would be more, I would favor more the leaving the 7.5. Does somebody have it still on their screen? That big decimal? Can you just leave that on the screen and then hit? You're gonna get all the girls, Alex. Slick, man. What'd you get? 90. See, so if it were me, I would tell you more to leave kind of that 7.5 feet, which means that when you round to inches, that would be closer to 90 inches. Whereas if you rounded early to 8 and then multiplied, that would give you 96. I'm more in favor of this, but sometimes it's hard to predict what the book and then many times they don't specify. Is the answer up here? It's not. Sometimes I forgot where I got it. Sometimes I get it from the teacher's edition. You see the answer. So I would tell you 90. Like that would be my opinion. But sadly, if the book doesn't specify, it's kind of hard to know what they're gonna put. What I have found though, in many cases, with the numbers that they use, it wouldn't come out to like 7.5. They'll usually use numbers that come out to like 7.999, or it's so close to 8 that even if you put 8 or if you put the other number, it roughly comes out to the same thing. But if they, I mean, look, that's a 6-inch difference. That's a pretty big difference. Do you understand what I'm saying? Or how many of you did the written assignment? You should have seen the same thing on those 2-part problems where they gave you like it kind of even looked like a triangle like the one you see up here, where they gave you like a bigger triangle and then they split it up into 2 right triangles, and they gave you like information on one of these, but then they end up wanting a side on the other one. Well, when you use trig, you're gonna have to round. So it's a matter of, do you want to round after you find the first side here and then bring it over? Or do you want to leave it exact? Because if I leave my trig ratio in here, and I don't actually put it into the calculator, do I leave it exact and then round at the end? I would always prefer to round at the end. Josh likes to round sooner, but we're gonna get to change that. Did you have a question, Elani? Let's try to do another one. Ooh, water skiing. A jump ramp for a water skiing angle makes an angle of 15 degrees with the surface on the water. Okay, so the ramp rises 1.58 meters above the surface. What is the length of the ramp to the nearest meter? What is the length? So which that's obviously a right triangle, and I guess this is a little bit vague, but it's not too bad. The hypotenuse, yeah. See now, because I mean, you could make the argument, well, geez, if they're talking about height, wouldn't the length be down here on the bottom? Do you think length and height would be perpendicular to each other? But no, because you don't see that part of the ramp. I mean, you as the human being, if you're gonna measure the ramp, you would measure the hypotenuse. So I would kind of go towards that. You want to call it what, R for ramp? Let's make a trig equation. It's 15, opposite and hypotenuse, so it is going to be sine, good. Wyatt, what is sine a ratio of? You're gonna memorize SOHCAHTOA before we get out of here, man. What is, when we memorize SOHCAHTOA, what's the SO in SOHCAHTOA? Opposite over hypotenuse. The opposite here being 1.58. The hypotenuse being a ramp. Elena, I need the paper. Elisa, sorry. You know, I do the same thing to her too. Kenny? Yeah, because now the one I'm looking at, the side I'm looking for is on the bottom. So actually, the shortcut so that you don't have to show any algebra stuff is just to put the R by itself and then put 1.58 divided by sine 15. Patty says that there's no unit conversion here because they want us to still use meters, but they want hundredth of a meter. So how many decimal places is that? 2. Did calculator? What's 1.58 divided by? Oh, he left. 6.10. All right. Jeffrey is determining the height of a building. He takes advantage of a nearby fire hydrant and the shadows that are cast on the ground. So you see 2 different right triangles there. The fire hydrant is 26 inches tall. Okay, that's already labeled for us on the diagram. The shadow cast by it is 17 inches long. The shadow cast by the building is 25 feet long, as shown above. Determine the height of the building. Round your answer to the nearest foot and show your work. And then after that, what is the value of z? So actually the first question here is actually not even going to be a trig question. This is the unit that we did right before trig. Does anybody remember what that is? Not special. No. The unit, like, this is, right triangles is considered kind of like a unit. That's why you're going to take a unit test. But right before that, what did you guys remember what we did? Shady. Pythagorean is still part of the same unit, right? Triangles. That's gonna all be on the test. Like, do you remember what the last test was on? The last big test. If you look at the grade book, huh? Similarity, good. Similarity. These are similar right triangles. Anytime you have similar polygons, corresponding sides are Not congruent. Proportional. Yeah, is that the first one here is actually proportion problem. So you'll when you see it, you'll remember it. First, we gotta set a scale. So for the scale, it looks like the ones that we have both shadows. So we can compare shadows in the scale. You can either do 25 over 17 or 17 over 25. I'll just do 25 over 17. Remember, we compare these two analogies, like saying like cat is to meow as Cameron is to wake up. Yeah. Uh, it shouldn't matter though, because the thing is, it's feet, inches. That's not when if you were to somehow have like mixed units and like maybe just one of them was in feet, then that would make a difference. Because it would be the same scale. In order to get inches to feet, you would divide both of them by 12, so it shouldn't make a difference. It's still apples to apples, I think. But thank you. That's really good. Like that's even for me. A lot of times I just overlook that. If I'm doing it by myself and I don't have to like try to communicate with a group, it's a little easier to focus on those details. But that's good that you do. So if 25 is the shadow of the building, then when my next fraction is height, I have to do height of the building. What's the height of the building, at least so far? What are they calling the height of the building? H. Josh, do you have H? Answer. And then what's the height of the fire hydrant? 26 inches. Okay. Now Hattie though, like she did, since she was paying attention to the units. Just remember that this first fraction was feet. What? No. This was feet to inches. Okay, so feet to inches. So this will be feet to inches. So when you get the height of the building, remember it's going to be in feet. 17 times h is equal to 25 times 26. So 17h is equal to, I have 26 quarters. I have so 650. Did I do that right in my head? Is that a complete disaster? No, I got it right. I know I got it right. Yeah. 7, and if you divide by 17, that's going to give you a decimal. Did it tell me where to round? If I can look. Round your answer to the nearest foot. Okay, so no decimals. 38. And then you're actually it looks like you're at an advantage over. You trying to be like Alex? There's gonna be only one Alex, right? It just goes on the board. It's easy. You just put it right on the board. A lot of the geometry classes haven't done using trig to find angle measure yet. You guys already knocked that out of the way, so that's one less thing we have to learn. Because for number 2, they want us to find z. Z is that angle of elevation. How do we use sides to find angle measures? Very good. And it's what is the height of the building and fire hydrant acting as? On a right triangle, what side is the, whether it's building or fire hydrant? Yeah, which leg? Yeah, opposite leg. And then what's the shadow acting as? Adjacent. So there's going to be tangent. Also realize, because these are similar right triangles, and I mean, we talked about this also before in similarity. I didn't mention it today, but I'll mention it. Why are those similar triangles? Do you guys remember when we did similarity? What makes those triangles similar? All these problems, you say that a lot of times they will say, oh, it's at the same time of the day. Did they say that? What produces shadows? Yeah, golden rays of sunshine. And a lot of, I was looking for the wording here, but a lot of these problems say took the measurements at the same time of the day, meaning that the sun was hitting it at the same angle. So that means that the angle that the sun is broadcasting the rays, that's congruent. Then because the because both the building and the fire hydrant are completely vertical, as Kenny said, yeah, angle similarity. You shut it down?
Yeah.
Oh. Okay. So so we just said it's gonna be inverse tangent, but which one do I put in? I actually have a strong opinion on this one. I would use the fire hydrant. Why do you think I would stay away from the building there? Yes? No. Well, yes, yeah, yes, but that's not the. I'm assuming we got H right. I know that we got H right. But what? No, what we just did, we just found H. But what did we have to do? What ugly thing did we have to do for H that we don't like doing? Yeah, rounding. Ugh, ugh. So yeah, I would go with the ones that I know are exact, which are 15, 17, and 26. And so let's see. Number 2 is going to be, said it was going to be inverse 10. And the opposite was the 26 or the 17? 26. So y at tangent is opposite over adjacent. So what is the inverse tangent of? Did they tell us where to round to? Find the value of z to measure the angle of elevation and round your answer to the nearest degree. Okay. 57 degrees. Let's see if we can do the next one on that one. A ladder is leaning against. You had one like this on the previous quiz. Stupid ladders. A 12-foot ladder is leaning against an outside wall. The angle of the ladder with the ground is 75 degrees. So that's here 75 degrees. When Carla solved for the height from the ground to the point where the ladder touches the wall, she used a 75-degree angle. Explain how Carla solved for the distance to the top of the ladder. Find the distance, rounding. So we know the ladder is 12 feet long. What Carla wants to know is this. So why don't you guys find that, and let's make sure. And they do want it in feet, so in nearest tenth of a foot, 1 decimal. Somebody find it for me first, and then we'll talk about how we found it. Let's do part A. That's all I want. Part A. Mickey, you got it? What'd you get? What'd you get? Huh? You're just lazy today? Oh, listening. So it's not Tarabio, Dakarai. To the sounds of the ocean. Alex has 11.6. Okay. I can't do this in my head, so we're gonna have to see it. Alex, how did you find that? I see it. We are looking for the opposite leg, yeah. For sure. That is gonna be sine, so we're gonna take the sine of 75. Okay. I'm gonna use h for height, but yes, you can use that if you want. And then over 12, and then because the h is on the top, then h is going to be exactly equal to 12 sine 75, which means that h is approximately equal to 11.59, and they want it to a 10th, So 11.6. Booyaka shot. He does it better. Big hands. Okay, part B, when Walter solved for the height from the ground to the point where the ladder touches the wall, he used a different angle. Explain how Walter solved for this distance, and then find the distance rounding your answer to the nearest tenth of a foot. When Walter solved, it makes sense. When Walter solved for the height from the ground to the point where the ladder touches the wall, he used a different angle. Yeah, I know, but I'm just trying to read it to see if they're implying that Walter made a mistake or something, and we're trying to identify his mistake. Yeah. Yeah, well, you don't even need 180 because the other two angles are complementary. So you can just do 90 minus 75, and that'll give you 15. No, yeah, I agree with you. I'm just sometimes especially when they use kids' names and stuff, like they're implying that like Carla did it correctly, but Walter did it incorrectly. So I'm just trying to make sure that they're not implying that like Walter put the 75 in the wrong place, and then having you find the wrong answer, and then asking you like, oh, why is this wrong? Type of a thing. That's why I just wanted to read it again. But yeah, I agree. I don't see anything to indicate that. So I would say that Walter, for some reason, decided to use that 15-degree angle. Do we know how I got 15? Just said it. 90 minus 75. And in any right triangle, if you take away the 90 from the right angle, that leaves 90 for the other two. It means that they're complementary. But now, if he's going to use the 15-degree angle, what trig ratio does he have to use? He has to use cosine. Oh, and you know what? This actually brings up a good point. Well, that's the thing. We're not using opposite because now it's going to be cosine. Now the height of that building is not opposite of 15; it's adjacent to it. And I tried giving you that little crash course and I was like, oh, you're going to see one problem on the. Well, I didn't tell you it was going to be one problem, but it ended up being one problem on the quiz where we said on any one given triangle, if you take the sine of one angle, it's going to be the same as the cosine of the other one. So since we're using cosine here, instead of doing like basically what I'm trying to say is what is the sine of 75 the same as?
Cosine of 12.
Not of 12.
Of 15.
Of 15. It's the same as the cosine. Put it in the calculator, check it if you don't believe me. Put sine of 75 without the 12. Put sine of 75 and then put cosine of 15 and tell me what you get. Wyatt has a fancy calculator. Then you're still on radians, which probably means that you took yesterday's quiz on radians, which maybe means that yeah, you just bombed it. Yeah, you gotta set it to degrees. Does anybody with degrees? Can anybody confirm that you got the same thing? Yes. All right. Cool. So cosine 15 is equal to 12. So the ladder is moved so that the base of the ladder is 5.8 feet from the wall. Determine the angle created between the ladder and the ground and show you fun. Okay, so now we're going to erase all this stuff. Is the ladder changing its length? No, it's still the same ladder, but now it's going to be moved 5.8 feet from the wall. Somebody tell me what this new angle is between the ladder and the ground and why. Okay. It means why. It could also mean because, yes. Languages. You want to know, believe it or not, if one of the hardest languages, if not the hardest language to learn, it's actually English. It's hard. It's typically harder for somebody um, that knows another language to learn English than vice versa. Yeah, because English has more double meanings than any other language.
I don't understand the English. This is language.
Did anybody bother to find this or yes, Hattie? All right, so she got 61 degrees. Shh. But just as important as what she got is tell me how she got it. You used inverse cosine. And yes, I agree. Because we're looking for the angle that is adjacent to 5.8, it would be inverse cosine. And then if she did it correctly, she would have done inverse cosine of 5.8, which was the adjacent over the lateral, which was 12. Inversely, you usually gotta hit shift. Everything is on there. And it sounds like you said you got what now? Oh, wait, they wanted it to a tenth of a degree, so 61.0. Okay. Kenny, you got the same thing? Explain the relationship. Oh, there you go. Explain the relationship between the sine of an angle and the cosine of a complement. Huh? They're congruent, sure. What is the relationship between the sine of one angle and the cosine of the other one? They are. We should be able to do at least one more. You need to know how to spell congruent. You can sound it out. Kangaroo. A hiker is standing 220 feet from the base of a hill. The angle of elevation. Remember, angle of elevation is from the bottom to the line of sight. Is 29. The angle of elevation from where he is standing to the top of the hill. It's 29 degrees. So how tall is the hill? So let's use this for hill. What trig ratio can we use here? I don't know if I have any evidence to back this up, but I feel like with a lot of word problems, like real world situations, tangent ends up being a very common ratio that I use. Like I would even argue that tangent gets used the most frequently. But again, I don't have anything to base that on. That's just more kind of and it's Wyatt. Tangent is good. Catch sucker toe. Kenny, the H is on top. So H is equal to 220, 10, 29. And they wanted this, see this one that they don't say how tall is the hill. So really if you round anywhere, I don't really care. So you can go 122. 122.9. Okay. So and then we're gonna be in feet. Alright. So then bring these notes back. Hey. Bring these notes back on Monday because we're gonna continue with the word problems. You might even want to like actually work on these over the weekend. To see if you can do them on your own. Yeah. You want to listen to a baby?